In this video, we're going to find out where the orphans in the F block belong in the periodic table. There are two rows of orphans, and they belong in rows 6 and 7 of the periodic table. Now, you've already numbered the first 20, but if we were to start in row 6, the first element in row 6 is number 55. Element 55's name is cesium, and the abbreviation is capital CE. Right next to cesium, in position 56, we find barium, which is an element that's used in medical imaging. Now, the element right next to barium, which would be number 57, is actually the entire top row of orphans. So I want you to write in that block 57 to 71 as follows. The first element in the F block, number 57, is lanthanum, and that row are called the lanthanides. So you can begin to imagine how unwieldy the chart would be if we had to use some scissors and cut it apart there and stick the lanthanides in, and we'd have another big huge gap. And that's why they're at the bottom. So then the element right next to that block would be element number 72. That element's name is hafnium. And if you can continue numbering across row 6, you should end up with number 86, which is radon. Before we go on, there are a number of elements in the transition metals that you're familiar with, so let's put them in the table. They are platinum, gold, and mercury. Platinum is element 78. Gold is element 79. Remember that gold's abbreviation comes from its Latin name, and mercury is number 80. Obviously, mercury's abbreviation is from the Latin word too. Notice that all of these elements are transition metals, and they're right on the boundary. Mercury, the element right next to mercury, number 81, would be in the P block. Mercury's the last one in row 6 that occurs in the D block. I'm just telling you these things to help orient you around the table using the things that you're already familiar with. There's one more in this row that you're familiar with, and I think you might be surprised to find out that it's considered a poor metal. That's lead, and it's number 82. But when you think about it, you've probably never heard of anything such as lead wire or something like that. So lead is probably weak on some of the characteristics of a metal that we talked about before. Okay, on to row 7. The first element in row 7 is going to be what number? Of course, 87, right after radon. And its element name is francium. I wonder where francium was discovered. Right next to francium, we find number 88, radium. And of course, that was discovered by Madame Curie, who is French. And then in the next box, we need to write the numbers 89 to 103, because those are the numbers that will encompass the second row of the orphans. Element 89 is actinium, and so that row are referred to as the actinides. For our purposes, the periodic table stops here. There are some other elements that have been discovered in row 7, but they exist for such a short time that they aren't of much interest to chemists. They are of more interest to particle physicists. Before we end this video, however, there's one element among the actinides that you are probably familiar with. That is element 92, which is uranium. Uranium was, of course, used in the atomic bomb that was detonated over Hiroshima. All the elements with a number higher than 92 have been artificially produced. The takeaway from this video is that the whole top row of the orphans are called the lanthanides, and they go in the periodic table right after element 56, barium, in row 6. And the bottom row of the orphans are called the actinides because the first one is actinium. And they go in the periodic table in row 7 right after radium. So we really don't need to call them the orphans anymore. Another thing that might be worthy of taking note of is that all of the lanthanides and the actinides comprise the F block, and that would be a lot less obvious if they were included in a long, unwieldy version of the table. as the table is, the S block, the P block, the D block, and the F block can be seen at a glance.